I may introduce myself. My name is Thomas Herse. I'm now in the tower crane industry since 20 years, and I'm responsible for the technical department at Liebherr. And I listened very carefully to that what you say, Jörg. It was quite interesting for us. So I realized we are working on some things. I realized also we have a lot of homework to do, and for us as manufacturer, it's fine that there are a lot of changes, there are some new things, so we can go on. So one point you mentioned, and you say the fiber rope, you hope it will work. So this we have in same, I hope too, and I'm sure. So I will introduce fiber crane. Is it that what you see? No, I think hopefully the right one. But best guess, what is a fiber crane? Oh, okay, you can say both of them. What do I want to say? We are, of course, handling with the new technology, but we are handling with some things we had in the long past. We had ages ago. When a crane, the left one is also a crane, starts ages ago, it has, of course, not the synthetic fiber ropes we are using now, but before the steel ropes, there were also a kind of fiber ropes. So a little bit coming back to the roots. So we start in 2009 together with Teufelberger. 2009, yep, the first idea for fiber rope at tower cranes or at the Liebherr Group, not only at tower cranes, also for the mobile cranes and our other divisions. The first idea, then the project took up to 2018, so that means we are within the development now since 10 years. And the guy always asks me, what are you doing in 10 years? Of course, it's a new technology, and we, and with our partner Teufelberger, we want to be introduced in the market, of course, a safe technology. We want to improve it. And so what did we do during this R&D time? We tested 85 kilometers of rope. We had 16,000 hours of test duration. So it was not in that way that we make one rope, we test it, and then it's fine. We had a lot of iterations. We had, in my point of view, between 10 or 15 different designs of ropes before we find, together with Teufelberger, this design we're currently using now. So we start before the last Bauma in April 2016 with a field test. I will show you afterwards some pictures from our first field test crane. We'll say something to that. So the last 3 years, we get a lot of experience. What will happen with a fiber crane in the field? And now, starting this Bauma, we start with the sales of 4 cranes, and we will start with the delivery in the beginning of the next year. So what did we do? We erect a lot of test benches, special test benches in Biberach. So we have 2 lifting benches. You see this big towers. These are our standard tower section. And we are lifting up. You see 2 million bending cycles we had in the test in the last 10 years. We lifted 140,000 times up and down, up and down. That we exactly know what is the behavior. What did we also, before we start with the field test, we had a 3rd test bench where we can work in a hot climate up to 80 degrees. We can work up to a cold climate up to minus 50 degrees. And of course, the crane is working at the sea, so there we have a salt environment. And also in Saudi Arabia, probably it's a little bit warmer. We have hot and sandy conditions. So we could simulate at this test bench what will happen with this fiber rope at the field. And we do it up to a failure of the crane, of the rope, of course. So at the end of the day, we know exactly what happened with the rope, when does it break, and what are the exact behavior of that. But the test benches are only one thing. So in relation with our customers and everybody, we find out some other things. What could happen at the construction site? Of course, hopefully a lightning strike is very seldom, especially to a rope. Normally, if you have a lightning strike, then it goes into the steel construction. But of course, there was a question, what happened if you have such event in the rope, in the fiber rope? And we do it in also a test bench, of course. We do it, you see it's hopefully good at the pictures. We do it 1 time, 2 times, and 3 times. You see there, of course, the rope is damaged afterwards. You can't use it anymore. But what was interesting, we make a break test, and if it happens during the operation, there will be no safety issue. The rope won't break. You have additional safety for that. Next one, it could be oftener. You see the guy who's welding approximately 1 meter above the rope. He do it for 30 seconds, 60 seconds, 90 seconds. You see then the coverage will be getting a little bit gray or black, but it has no influence to the safety of the rope. And next one, I think this is the most interesting point we get. I have to be fair, I can't compare it to a steel rope. We never made such a test with a steel rope. Wear resistance, what does it mean? We get the feedback from the customers, okay, the rope normally dies after 1, 2, 3 years when it touches the construction, when it touches a concrete edge or something like that. So you will see the next slide, due to this special design of the rope, we have this coverage, and we make a lot of tests. I bring you 2 pictures. A small angle, I think I need to explain it a little bit. I think you see here the edge of the concrete, and the small angle means you have only some touch to this edge. We have a preload of 2 tons at the rope. That means in a 2-fold operation, 4 tons, this is a very heavy concrete bomb. Yeah. We do it with 2 tons, also with more tons, but with 2 tons, I think is an interesting thing. And if this happens, we're always moving this rope here. You see here the test bench, up and down, and we can do it 15,000 times with this small angle. A bigger angle means, in that case, if I have it right in my mind, 2 degrees. So if you see 2 degrees, this is a lot. And you can do it 80 times before the rope looks like that. You will see it in the next slides. You can work with both of these ropes at this condition. And I think this is a very, very important issue. What happened if you touch the construction? So please have this in mind. So coming to the fiber rope, I think it's also very important to see what are the differences between a steel rope and the fiber rope. You have a steel rope in mind. The fiber rope, we have an inner core. You see this is a gray construction. This gray construction is the load-bearing structure. That means, in difference to the steel rope, for the steel rope, the whole construction is supporting the load. For our fiber rope, only the inner core is a load-bearing structure. Then you have the optical indicator. I think this is most important for you as a user. The optical indicator, normally if you see a sign, a red traffic light, then you have to stop. So we choose, of course, the color red. And we have outside this outer coverage. What does this outer coverage do? This is a protection and the discard criteria. You know the discard criteria is from the steel ropes. If you see if you've broken parts, 6 or depending on the diameter, then you have to discard the rope. It is much more easier at the fiber rope. So Unfortunately, I guess it's a little bit small, but I will explain it. There are several steps. They will be described exactly in our manual when you get this crane, and of course you get the manual and all information necessary for this fiber rope. The green one at the top, of course, this is a new one. So everything is fine, the coverage is fine, everything is okay. After using this rope, a degree of damage of 40%, what happened there? The core and the indicator is completely protected, and you see it hopefully a little bit, the colored fiber outside are wear a little bit. If you're at 60 degrees, you see all the colored fibers are wear out. You have the white and the gray ones. But the important thing, the inner parts are 100% protected. There can be no sunlight, nothing can be go into the core. What is the hand? So what is the important part? So you see that if you are using a crane, you would say, "Oof, we need to remove it." Of course, there we see some red points. Of course, as you see, we are here at 90% of the damage of the degree. You see some of these braids, maximum 2 braids are visible. You see it here. This would be 90%. And of course, this will happen in the real life in approximately 1 year. So if the rope looks like that, then you see more of this red indicator. And at the end of the day, 100%, more than 50% of the diameter, you see the red indicator, and then you have to remove it. This is the discard criteria of a fiber rope. And we believe it's very easy for you as a user to see this, to handle that. And to say something to the standards, there is a FEM standard and the ISO standard in development. It will named by safe use of fiber cranes in mobile cranes and in generally in cranes. And there it is described. There's another important issue. What does it mean if the rope looks like that? In line to the FEM standard, it means if the rope is in this condition, you have 40% of the maximum bending cycle reached. It means you keep out 60%. You could use this rope the double time. But this is the safety distance to the break of the rope, and is defined in the FEM standard. Currently we're working on ISO standard. In my point of view, in the next year probably this ISO standard could be published. Yeah, if something happens, we are waiting 3 years for this event. Of course, this is one of the important points. If this was at our prototype crane in my point of view, Ravensburg, there are 2 cranes touches. And you see there's a cut in the outer coverage. You see the red sign, of course. This would be the indication, if you have in mind the discard criteria, to remove it. If this happened after 3 months, then it's really bad. Because I think after my presentation, there we can talk about what are the prices and so on. This fiber rope will be in a range of approximately 4 times more expensive than a steel rope. So it's a big investigation. So our main focus was to have a look, what could we do if something happened? So, oh, it's the wrong one. If something happened, don't laugh. It is the prototype version at the moment. Comparing to a steel rope, if you have a steel rope damaged, you throw it away. You need to discard it. We find a solution together with Teufelberger. If, and this is very important, if you damage the core inside, the load-bearing structure, then you need to remove the rope. This is clear. But if it's that way, if only the outer cover is damaged, the core must be undamaged. As it's locally limited, If you damage the rope for 2 or 3 meters, then it will be very hard to repair it. But there will be the solution to tape it. The final solution will look a little bit different. We are now in the final work with our colleagues at Liebherr and the colleagues at Teufelberger to finalize the solution, but it will look similar. What happened there, for the first view, it seems to be a little bit untypical solution, but this is nearly the same material like the fiber rope. So after 2 or 3 lifts, this tape will be worked in the outer coverage, and it will take the function from this coverage. So you can repair it, you can use it. It was really interesting seeing at the construction site, they call us, the fiber rope is damaged, come, you need to bring a new one. Our technicians traveled to the construction site. It was easy. Ravensburg is 20 kilometers, half an hour away from us. They go to the construction site, and 30 minutes later, they went away and say, it's fine, you can work on. Okay, so the construction site was very happy that they don't need to get the crane down for 1 day to remove the rope and so on, that we could repair it within minutes. And I think this is a very important issue for the fiber rope, that it is able to repair, of course, under these conditions that the load-bearing core is not damaged. What are the benefits? Mostly we have these 5 points. I need to see, I have to hurry up a little bit. As I already mentioned, it is very safe. You have to look for red. You see this drum, it is from our test bench. There you see we tested very, very long. If you see this rope, the second from left, you need to remove it, of course, but we tested up to the end, and this is the reason for this picture. So very easy, just look for red. The handling, we get also a very positive feedback from our service technicians. Of course, due to the dead weights, it's much lighter than a steel rope. It's much more easy to handle. And another point, you don't need to lubricate it, the left picture. If you do this, and you do this very often, then the lifetime, the bending cycles will reduce by 20 or 30%. If you do it very often, then you can buy a new rope a little bit often. For us, it's okay, maybe for you not, so don't do it. But if you do it, it's no problem. This is what I want to say. But you have in mind what it costs to lubricate the rope. The lifetime at our test bench, we see it is approximately 10 times of the lifetime. We know that the reality at the construction site won't be. Our conservative guess is that between 7 and 9 years could be a typical lifetime for a Solite, if it won't be damaged, of course. Intelligence, only a smart part. We are also working on condition monitoring for these fiber ropes. That means, of course, to discard this criteria, is that what I mentioned, but we are also working on the algorithm where you get a calculated lifetime. We are counting the bending cycles. We know the high underhook from the configuration. We know the jib lengths. We know exactly where do you have the pulleys. And so we are calculating the lifetime. And I think this is a very interesting thing, a first step in this condition monitoring, and to give you, rough information, what is the current condition of the rope, so that you can also have in mind a kind of preventive maintenance, that you know, okay, within the next year probably this rope will be necessary to remove. And of course the big thing is, due to the lighter rope, only 20%, we can, depending on the crane type, you will see it afterwards, approximately load 20% more. To get it a little bit better, what does it mean? A 340 ECB, the crane we showed at the Bauma, and The steel version is a 340 ECB12. The hook block, the dead weight of the hook block is 500 kilograms. The rope for, I need to mention, 50 meter is 200 kilograms. So in sum, we have 700 kilogram dead load. And to make a small, small description of the crane, coming back to that, what Jörg said, comparing to the preceded 285 ECB, we optimized the steel construction of the jib by approximately 30%. So the jib is lighter, approximately 10%, and can lift 50% more. So I agree to Jörg, this is a big issue for us, using new materials, using new calculation methods, and so on, to get the dead weight down. The big issue then is, of course, the fiber rope. So the fiber rope version of this crane is 370 ECB fiber. The hook block is 260 kilograms, so approximately the half that you can also have in mind. For our cranes, it will be mostly approximately the half, a little bit heavier. And the rope is 40 kilograms. But there you see, of course, this is only 1/5. But if you say the sum, the hook block brings more. Where does it come from? Or could we make the hook block lighter? We could, but the problem would be the construction site wouldn't work with the crane anymore. Because if you make the hook block lighter than that, then the hook block would be swinging, would be more wind, for the wind attack would be heavier. If you have a little bit stronger wind, then the hook block will be blown away. So it would be hard to work with that. This is the reason we don't reduce this hook block anymore. At the end of the day, it means 400 kilograms more for the 370 comparing to the lifting power of the 340. You can imagine this is for the complete load chart. So you move the load chart up by at minimum 400 kilograms. So talking about experience, so what did we do the last 10 years? Currently, we have 40 cranes at construction sites in France, in Netherlands, in Belgium, in northern part of Germany, in Austria and Switzerland, and mostly in the southern part of Germany. To be fair, it's not so far for us to have a look for that. Of course, these are all prototypes, and we are very keen on it to visit this crane. Each of this crane would visit 1 time a month by a service technician to check the behavior, to talk with the crane driver. And so I think we have a lot of experience. In this month and next 1, 2 or 3, another cranes will come, so that we can say that we have, for this complete new technology, a lot of experience in test and in the field. Okay, this was our first crane. I think it was, the left picture was the first construction site, the right one on top was the second construction site. 172 ECB is working since 2016. Has now seen 4 different construction sites. What we do, after 2 years, we removed the first rope of this crane. Not because we see we need to discard it because the outer coverage is damaged. We want to know, we want to bring it back on the test bench to see what was the lifetime. And in this 2 years, we need we use approximately 4% of the lifetime. And if you recalculate this to this FEM criteria, starting at 40%, you have to remove it. Theoretically, it could be more than 10 years. But we don't want to promise this because, in my point of view, it won't be the reality. But all that, what we see at the test benches, at the fields, and so on, bring us to this information for up to 10 years. Yep, only some small interesting pictures. From Paris, we have the ECB there, working in Brussels. Especially the right picture should show the spooling behavior is I say similar to a steel rope. What did we do at the construction site in Brussels? We put a little bit too much rope on it. We put there 300 meters, in my point of view. That would be fine for the 250 in this configuration, for 105, 110 meter high on the hook. This crane is erected. Eric knows it probably better. I think 50 meters or something like that. We want to know what is the behavior if you are working in the top layer. So we are working there up to the 5th layer, and there you see the spooling behavior is it's quite perfect. And this we do also at the field test. We don't work under perfect conditions. We choose hard conditions because we want to know how's the behavior there. Starting 2020, I say with 4 fiber cranes, the 240 and 2 different variants, 2 and 12 tons, for the 10 and 12 tons, sorry. The 10-ton version has up to 250 kilograms more. It depends on the difference of the hook block, because the hook block is lighter, so smaller cranes have not the big benefit like the bigger ones. The 240 is up to 350 kilograms. Then the 278, the steel crane variant, is 250, can bring up to 600 kilograms. 400 kilograms are from the Solite. 200 kilograms are by some other things we modified at this crane. And as I mentioned, this 370, 400 kilograms. So this is the range, 200 meter tons up to 400 meter tons. I'm happy to see that, what Jörg showed. It seems to be an important crane size. So we are working on the right size, fine. And yeah, starting in 2020. So to finalize, what is the added value? The added value is that what we see, it's more safety. It's an easier, faster identification of the rope conditions. You see the condition of the rope. So it's easy to handle. It's 20% of the dead weight. You don't need to lubricate it. It's much more easy for the assembly, for the change, for the transportation. The handling capacity, of course, you can increase the load. And the other point, what I didn't mention, but due to the reduced dead load of 400 kilograms or 600 kilograms, you can increase the speed, so you can work with the same load approximately 5% faster. Okay, 5%, to be fair, is not so much, but it's a little bit. You can increase the construction side, the speed of the construction side a bit due to reducing of the dead weight. The hook height is also a very important point. Our customers has normally 2 or 3 different tower systems. Normally not the 6, as you mentioned, but 2 or 3 is the standard. And of course, for us as a designer, it's always hard to increase the crane size by using the same tower system. And for the 370 ECV, we are using the 21HC, or in the old naming, 256HC. And we will see from the name, it comes from the steel crane. The rope, the fiber rope crane can go up to 370 meter tons. So it's more efficient use of the tower systems you always have. The longer life, at the end of the day, we believe it will reduce your total cost of ownership due to the longer life, due to the less maintenance you need for this comparing to a steel rope. And finally, of course, load capacity is always an issue, and 20%, I think, is a word. So 5 minutes too long, but hopefully it's allowed to have some questions. Yeah. This is what I say. At the moment, we have 2 different diameters. 20 millimeter diameter is for 10 tons. 22 millimeters is for 12 tons. These are the first diameters we start. At the moment, please have in mind that we are approximately at the fourth of the steel rope, a little bit depending on with which steel rope you compare it, approximately the fourth, therefore, 4 times more. Yep. Another questions? Yeah.
Do you need to change the winch?
Yes. Yeah, we need to change the winch, or not theoretically not the complete winch. It is the other drum, the motor, and the gearbox, of course, are the same. Why? The diameter is a little bit different. So we typically have at a steel rope crane 22 at 20 millimeters, where we have 22 for the fiber rope. And there are some other issues for comparing the fiber to the steel rope with the spooling, where we need a different drum. Yep.
Okay. Thomas, just a quick one. Do you have any experience at the moment on the super high rise? That it means above the 100 meter,
Yep.
because of the dead weight is going
Yep.
then up. You have to reduce the load. Maybe you can say something about that. First
Yep.
point. Second point. What is your experience to cut the rope?
To?
Cut the rope. Because of sometimes we have to cut out the rope if there's a damage on it. On the steel, it's relatively easy how it looks like with the fiber rope.
Okay.
Thank you.
So first point, high-rise building. At the test, you see, we had was quite high. We had at the moment the highest crane at 60 anything. What we see at the construction site, this is the feedback from our customers, that the interesting thing for high-rise building is the turning of the pulley block. And from the technical point of view, the internal moment of the fiber rope is less than a steel rope. So from the theoretical point of view, for the high-rise building, the fiber rope is more suitable than a steel rope. What we see currently is exactly that for each high under hook we have, the hook, the pulley block is working extremely perfect to going down. And we hope, because I want to have also a construction site with extreme high buildings, so if somebody has extreme construction sites, please contact me. Hopefully we will have in the next months, I don't know exactly the current situation, a construction site in Stuttgart with more than 100 meters for 370. I don't know whether we get this or not. Probably I need to inform before. From the theoretical point of view, it needs to work better than a steel rope. What we do, the hook block is prepared to add some additional weights. If you have extremely highs and you see, okay, there's a turning hook block and you want to increase it, also the wind, some problems with the wind, so you can add some steel plates. It's everything prepared for that. But if you go up, I think this is a big benefit. You have the less dead weight from the fiber rope. You don't have to decrease the load chart as much. And this will be in that way. That would be the first one. The second one with cut. You only can cut the rope at the drum. At the moment, it's not able to cut the rope at the jib tip because this is a kind of the connection. We have the kind of the connection so that we need to add this connection in the factory. If you need to do it, you need to contact us. So if there is a cut in the top, then we could do it together with Teufelberger. But this will also a future issue to develop a technology to give you the possibility to put this end connection also at the field. I think there's one guy from Teufelberger. He listened very carefully what our customers want to have. So, yeah.
Yeah, Thorsten Hesselbein of Liebherr Biberach. Thank you, Thomas. I just want to add something because we heard, we hope it will be a success, and we did some test machines, and I see the success is coming because after the Bauma we sold more than 40 units now. So I see that it will be a success, and we have convinced our clients already, and it will go on after this long period of testing. Thank you.
So, I answer questions? Fine.
Thank you
But-
very much, Thomas.
Okay, then I answer no questions, probably at the coffee.
Yeah, just conscious of time. Thanks very much.
Bye.